Hello everyone, in this lecture we are going to start with our second example or our second type of special reinforced concrete structure, which is our beam ledge. So when it comes to our beam ledge, the design of my beam ledge is very similar to that of a corbel. However, there are a couple of minor differences which we will talk about. So when I talk about a beam ledge, basically my beam ledge is uh, it can be a pre-stressed a pre-stressed reinforced concrete structure, and its main function is to support pre-cast concrete structures such as hollow core slabs and precast concrete precast beams. So if we look at this image here, we can see that we have our beam or our beam ledge. This here is what we call our ledge, and you can see that this here is a space that is created to support my hollow core slab or my precast beam that is going to be placed in this location. So now when we want to design for a beam ledge, just like what we did with our corbel, there are several failure criteria that we need to take into consideration when we design for our beam ledge. So let's go over them one by one. So if we look here, the first four criteria are similar to my corbel. One, we have our shear plane. So we said before, we have a shear force that is being transferred or that is being applied, and this shear force has to be transferred from my ledge to my beam or to my column. And in order to do that, we have to add shear reinforcement to ensure the safe transfer of my shear force. Now, second, we have our tension tile, which again was due to my VU times A. This VU times A creates a moment which results in tension top, compression bottom. We need to resist this tension, and in order to do that, we need tension reinforcement in addition to the direct tension that is being applied by my NUC due to temperature conditions that creates restraints on my beam, which will create direct tension. So we need to make sure that we reinforce our beam ledge, just like my corbel, against this tension that is being applied. Now third, we have our compression strut. Our compression strut is due to the reaction of my concrete on the shear force that is being applied. Now this reaction might cause my concrete to break. Now we do not want that to happen, so what we do is we depend on my F prime C or my beam ledge thickness, try to increase it in order to avoid compression strut. And fourth, which is the final type of failure condition that is similar to our corbels, is my localized bearing. And we said that here along this location we might have failure due to my shear force, and in order to avoid that, we either add an angled steel or a steel angle here, or we add a reinforcement along the corner. Now, the fifth type, which is separation. So when I'm talking about separation, okay, what I mean is when I have a shear force that is applied, what's going to happen is that this area here is going to try to separate from this area. So I'm going to basically have two parts, which is this part, let's just, this part here, and this part here. So I have part 1 and part 2, which is being separated. So we do not want that to happen, so we add a reinforcement to prevent that from happening. Now, my final type is punching shear. Now, to better understand punching shear, let's go to this image here. Now, this image represents my punching shear along every red dot here I have a VU that is being applied. Now we can see here that my VU caused a portion of my ledge to be removed, and this is what we call a punching shear, and we need to make sure that this does not happen, so we need to accommodate for that and reinforce against punching shear. So these are basically the 6 modes of failure that we have when we talk about our beam ledge. So shear plane, tension tie, compression strut, localized bearing separation, and punching shear. And we have to reinforce against all of them. Now when it comes to the reinforcement of my beam ledge, let's look at this image. And this image represents the reinforcement that is executed on site. So this is the reinforcement that we usually go for. It looks like this when we are designing for a beam ledge. Now, we are going to go and talk about the reinforcement of each and every shear failure or a failure condition one by one. So we are going to start with my first failure condition, which is shear. So we said that we require shear reinforcement in order to maintain or to ensure the safe transfer of my shear force from my beam or from my ledge to my beam or to my column. From my ledge to my beam. So, in order to maintain the safe transfer of this shear force, we need shear reinforcement, and we said our shear reinforcement is basically a stirrup with 2 legs or with 4 legs. So, this stirrup here, its main function is to resist the shear force. However, here we want to add another functionality for this stirrup. So we said before that due to VU times A, I'm going to have tension at top and compression at bottom. And we require tension reinforcement in order to resist this tension force. In addition to the TU that is being applied, we would require tension reinforcement because this NU is resulting in direct tension that we need to take into consideration. So what we will do here is we are going to design this stirrup to resist 1, my shear forces, and 2, the tension that is being applied by my VU times A as well as by my NUC. So this stirrup is going to resist a combined effect of my tension and my shear. And this is one main difference that we have between my Corbel and my beam ledge. So this way we can make our execution, or we can execute our reinforcement in a much easier manner. So now instead, the way that I'm going to distribute my reinforcement is going to be along this direction here. This is going to be a stirrup 1, 2, 3, 4, 5, 6, 7, 8 along the length of my ledge. So if you look at this image here, we are looking at this side and we have a reinforcement placed here 1, 2, 3, 4, and we're going this way like this. So this is when it comes to my shear stirrups. Now, a second type of reinforcement that we said that due to VU, to make sure that my VU is being transferred to my column, we place a steel hanger here, just like this, to make sure that my tension is being transferred safely to my column. Now, in our case, we are not going to place this steel hanger. Instead, we are going to place a stirrup. However, now this is the first stirrup that we placed that we talked about now. This one, we just talked about it. Now, this stirrup, we need to take into consideration that this leg here, this right leg, is also going to resist the combined effects of shear and the Vu times a tension that is being applied, the tension that is being transferred from here to here. We need to take that into consideration. So when we are calculating or when we are designing for this leg specifically, we need to make sure, because this is a critical leg that is also resisting a combined effect of shear that is applied along this plane and uh, tension. So if you want to look at the different types of reinforcements that we have, let's open this image here. Okay, so this image tells our story in a better way. So we can see that we have our primary reinforcement, which is the reinforcement we said our stirrups that we mentioned, our first reinforcement. We said we have our hanger reinforcement, which are these reinforcements, the ones we talked about where we need to consider the leg, the design of my leg to make sure it handles the combined effects. And we have my beam stirrups. So my beam stirrups, if you can notice, they are placed in between. So here I have a steel plate, and here I have a steel plate. Now these beam stirrups are placed in between the steel plates to take into consideration any other type of loads that are being applied along this direction here, because there are no loads. So in case there was any type of load, we put these beam stirrups here. And finally, we have our minimum reinforcement, which is here to make sure that my concrete is distributed the right way when we are pouring concrete. So what we have is we have our primary reinforcement, our hanger reinforcement, and minimum reinforcement, and beam stirrups in between. These are the main reinforcements that we are going to have. And of course, inside a beam, just like when we design for any beam, we are going to have flexure reinforcement, which are the reinforcement in red here. So now we have covered the different types of failures that we have and the different types of reinforcement that we are going to use. So now we can move on to our software in order to design for our beam ledge. So I'll see you in our next video.